Today, I'm going to be walking you through SAT type questions involving linear functions, which is what we've been studying. Hopefully, by the end of these 8 examples, you feel more comfortable answering SAT type questions involving linear functions. Feel free to pause this video or rewind as you're watching it so that you fully understand each question in order to complete tonight's homework. SAT type question 1. The graph of y equals f of x is a line in the xy plane that passes through the point 0, 2 and has a slope of 5. Which of the following equations could define the function f? A, B, C, or D? When reading SAT type questions that are math word problems, it's always important to pick out the key words or terms that you know and any numbers that might be relevant or helpful when solving the problem. Reading this problem, the first thing it gave us was a point 0, 2 that lies on this line. The second important thing that this problem gave us was the slope of 5. Because this is a line, all lines generally have the equation y equals mx plus b. That is the slope-intercept equation, where m represents the slope and b represents the y-intercept. So plugging in the numbers or information that this problem gave us, when it said the line has a slope of 5, that would be our m value. Now, it doesn't tell us directly that the y-intercept is 2. However, if you take this point and you graph it in an xy plane, that point, 0, 2, would be over 0, up 2, and it would lie on the y-axis, which means this line passes the y-axis at positive 2. So that would be our b value. With the equation that we found, you should see that is the same as option D. Remember that function notation, y is the same as f of x. They both represent the output. Moving on to question number 2. Which of the following could be an equation for the graph shown in the xy plane below? Well, when we're looking for an equation of a line, which is what's graphed there, in class we discussed that you must find the slope of the line and the y-intercept of the line in order to write the equation. Looking at this line, the easiest thing to find is the y-intercept, which is where the line crosses the y-axis. You should see that it's at the point that I'm placing a blue dot on. If we try to find the value of that point, we would have to use the scale that's given to us in the bottom left of the graph. Notice on the y-axis they put a 1 at the first horizontal tick mark line, which means we are counting by ones on the y-axis. So the next line would be 2, the next line would be 3, and the line we're looking for is 4. This graph crosses the y-axis at 4. To find the slope, we must find a second point on the graph. So I'm going to place another point down at the bottom right corner where the line is passing through the x-axis. It doesn't always have to be the x and y-axis intercepts that you use. I could have used the point kind of in the middle there. It's up to you, but you do need a second point. To find the slope, I'm just going to count the rise over run. To know the run, I have to look at the scale on the x-axis. Notice by the origin, the first number they give us on the x-axis is 2. which means we're counting by twos. So the next line would be 4, then 6, 8, 10, and lastly 12. So to count the slope for this graph to get from one point going left to right to another point, I would have to go down 4, so I'm going to put a minus 4, and over 12. So my rise over run would be down 4 over 12. I could have also went down 2 and over 6 and if I simplify both of those, I find the slope of negative 1/3. All three of those fractions are equivalent, but the negative 1/3 is the simplified form of negative 4/12 and negative 2/6. So to write my slope-intercept equation, which is y equals mx plus b, I'm simply just going to substitute the slope I found in for m and the y-intercept I found in for b. You should notice that option C is the same as the equation that we just found. Remember that y is the same as f of x. Moving on to question 3. The graph of a line in the xy plane has a positive slope and intersects the y-axis at a point that has a negative y coordinate. Which of the following could be an equation of the line? Like I said previously, it's important to pick out key details when reading the problem. The first thing that should have stood out is that we want an equation that has a positive slope. The second thing is that we want a negative y coordinate at the intersection with the y-axis. Thinking about lines, our slope is always our m value. And the point that intersects the y-axis is always our b value. To find the slope and y-intercept of options A through D, we would have to rewrite them in slope-intercept form. That means we want to get y by itself for each of them. Let's start with option A. For option A, to get y by itself, the first thing you are going to want to do is add 3x to both sides of this equation. When we simplify this, the negative 3x and positive 3x would cancel out, and we would be left with 2y on the left side of the equals. On the right side, negative 5 plus 3x cannot be combined because they are not like terms. And because we are trying to find the equation of the line, we want the term that has our input x to come first, which is the positive 3x. And the term that does not have a variable with it, which is known as our constant, to come last. Y is still not by itself. Right now we have 2y, which is the same as 2 times y. Multiplication is implied. So to get y by itself, we would have to divide by 2. Because this is an equation, whatever you do to one side, you have to do to the other. So we need to multiply the whole right side by 2, or each individual term. When we simplify this, on the left side, the 2's would cancel, leaving us with y. On the right side, we would have a positive 3/2 x minus 5/2. Now, if we stop here and ask ourselves, is this the answer? Well, does it have a positive slope like we wanted? Yep. Does it have a negative y coordinate for b? Well, it has a negative right there in front of the 5/2, so yes. So this is the answer to this question. However, if you didn't know that right away, we could convert B, C, and D, just like we did with A, into slope-intercept form. I'm going to take a moment to do that to talk through why B, C, and D are not the answers. With B, if we were to write that in slope-intercept form, we would be left with y equals positive 3/2 x plus 5/2. If we did the same check we did with A, we would see that it has a positive slope, which is great, but it has a positive y coordinate. We want a negative y coordinate for the intercept, so this is not the answer. Let's check C. If we were to rewrite C in slope-intercept form, we would be left with y equals negative 3/2 x minus 5/2. So let's do the check here. This one has a negative slope. We wanted a positive slope, so without even checking the y-coordinate, we know this is not the answer. If we check the y-coordinate, it does have a negative y-coordinate, but because the slope is the incorrect value, this is not the answer. Let's check D. If we write D in slope-intercept form, we would be left with y equals negative 3/2 x plus 5/2. Again, just looking at the slope is negative 3/2, which is not a positive slope, so this is not the answer. Also, this has a positive y-coordinate, so again, still not the answer. So A is the only one that satisfies the positive slope and negative y-coordinate. Moving on to question 4, the graph of the equation ax plus ky equals 6 is a line in the xy plane, where a and k are constants. If the line contains the points -2, -6, and 0, -3, what is the value of k? So again, we want to pick out key important information to help us solve this problem. We want the value of k, which is going to be the coefficient on our y variable of the equation when in standard form, which means x and y are on the same side of the equals. Because we're given 2 points, this is our first coordinate point, x1, y1, and this is our second coordinate point, x2, y2, we can use the slope formula, y2 minus y1, over x2 minus x1 to solve for the value of m, our slope. Using substitution, we would have -3 minus a -6 over 0 minus a -2. Be careful with the slope formula for your double negatives. Whenever you subtract a negative, that always becomes a positive. So in the numerator, we would have -3 plus 6, and in the denominator, 0 plus 2. Simplifying that, we would have 3/2. This is the value of our slope, m. We can solve for the value of our y-intercept b by picking a point. I'm going to pick the second point, and the slope m that we just found, and substituting it into the y equals mx plus b equation. We would have -3 equals 3/2 times 0 plus b. Well, anything times 0 is 0, so we would be left with -3 equals b. Using our b value and using our m value, we now have the equation y equals 3/2 x minus 3, which is the equation of our line. In this form, though, it's not very helpful to telling us what the value of k is. We need to rewrite this equation back into standard form to find the value of k, which means we want x and y to be on the same side like it is written above. To do that, we would have to subtract 3/2 x from both sides. Simplifying, we would have negative 3/2 x plus y equals negative 3. Now x and y are on the same side, but our equation equals negative 3. We want our equation to equal a positive 6, as it's written above. So to do that, we would have to multiply this whole equation by negative 2. Using distribution and multiplying everything by negative 2, a negative 3/2 times a negative 2 would be a positive 3x. And positive y times negative 2 would be a negative 2y. And negative 3 times negative 2 is positive 6. Looking at this equation now, our a value would be 3, and our k value would be negative 2. So the answer is A, negative 2. So again, to solve this problem, we had to find the slope using the 2 points that were given to us, the y-intercept by using a point in the slope that we found, and then rewriting the equation into standard form by getting x and y on the same side and multiplying the equation by negative 2. This is a pretty complex problem, but luckily for you, there are multiple ways to solve. So I'm going to do the same problem over again, but I'm going to use a systems of equation to solve it. Now, we've been doing systems of equations before in class through math review, so hopefully you recognize how to solve this. Each point represents an x and y value given to us. So I'm just going to label them both with an x and y. We've used substitution before when given an equation, so that is simply what I'm going to do. I'm going to substitute the value of x in for x, and the value of y in for y. That would give me a times negative 2 plus a k times negative 6, and it would have to equal 6. Doing the same thing with the second point, plugging x in for x and y in for y, I would have a times 0 plus k times negative 3, and again, that equation equals 6. This can be rewritten because a times negative 2 is a negative 2a, and negative 6 times k is a negative 6k. And rewriting the second one, a times 0 is just 0, so that kind of disappears. And k times negative 3 is a negative 3k. I'll kind of separate these two so we know this is the first system and we're kind of rewriting it to the second system. Now, looking at the second system, you should recognize that you can solve for k in the second equation by dividing both sides by negative 3, which means k is negative 2. So we just actually found the value of k, which is still option A, negative 2, but by solving a system of equations. If the question had asked for the value of a instead of k, we could have actually plugged k back in to find the value of a. So I'm actually going to do that. What is the value of A, just in case it had asked that. Well, we would plug this back into our K value. Sorry, I don't want to skip steps for you in this video. And we would have got A as 3 if it had asked for the A value. So on the previous slide, we found A to be 3 and K to be -2. We found the same thing with this example as well, using the system, just a different way to solve. So whatever you feel most comfortable with, definitely use that method. Moving on to question number 5. In the xy plane, the line K intersects the y-axis at the point 0, -6 and passes through the point 2, 2. If the point 20, W lies on line K, what is the value of W? So this has a lot going on with it and a lot of ordered pairs, but remember, whenever it gives you 2 points on a line, the first thing you should typically think of is slope. So that's what I'm going to do here. I'm going to let the first point that they gave us be our x1, y1, and the second point be our x2, y2. And I'm going to find the slope using the slope formula. We'd have, using substitution, -6 minus 2 over 0 minus 2, which is -8 over -2, which simplifies to +4. The second thing I'm going to do is find the y-intercept. I'm going to choose the first point and the slope that we found. Again, this is our m value. And substitute them into the y equals mx plus b slope-intercept equation. Now, hopefully, while I'm doing this, you recognize that 0, -6 is the y-intercept because it'd be, if graphed, on the y-axis, just like the first problem we did. But we can also solve for it just to verify that. 4 times 0 is 0, meaning b is -6. So that's our b value. So we can now write the equation of this line. This line would have the equation, just kind of putting these together, y equals 4x minus 6. Now, this doesn't really tell us what the value of w is yet, but it says the point 20, W lies on line K, which means 20, W is an XY ordered pair. It's kind of like our third X value they give us in this problem and the third Y value they give us. So we can substitute those values in W for Y and 20 for X. And simplify. 4 times 20 is 80. 80 minus 6 is 74. And we just found the value of W. So notice, we've kind of repeated this process of finding the slope and using the point and slope to find the y-intercept to write the equation of the line. This is something we've been practicing in class, and you've practiced on homework, and it comes in handy when solving SAT problems that involve linear functions. Moving on to question 6. In the xy plane, line A has a slope of 2. If line B is perpendicular to line A, which of the following could be an equation of line B? Well, picking out key information here, A and B first are two different lines, and when they cross each other, they are perpendicular. Perpendicular means they have opposite, reciprocal slopes. So if line A has a slope of 2, then line B would have to have a slope of negative 1/2, which is the reciprocal of 2 over 1. We can kind of put that 2 over 1 to see that if we took the reciprocal, it would become 1 over 2. So we want to know which of these lines have a slope of negative 1/2. Well, looking at them, they are not in slope-intercept form, so we would have to do that just like we did in a previous problem by isolating for y. I would start with equation A. To put this in slope-intercept form, first we would add 10x to both sides. The 10x's would cancel on the left, leaving us with negative 5y equals 10x plus 20. Remember, 20 plus 10x are not like terms, so they cannot be combined, and we want the term with our input x to come first. Next, we would divide everything by negative 5, and we'd be left with y equals positive 10 over negative 5 would be a negative 2x. And 20 divided by negative 5 would be negative 4. So A does not have a slope of negative 1/2. It has a slope of negative 2, which is not right. If we repeat this process with B, which is 3x minus 6y equals 14, and we wrote that in slope-intercept form, we would have y equals a positive 1/2 x minus 14 over 6. This slope is positive 1/2, which is not negative 1/2. If we did this with C, which is 4x minus 2y equals 17, we'd be left with a y equals a positive 2x minus 17 over 2. This slope is positive 2, which is not what we're looking for, negative 1/2. And option D, which is 6x plus 12y equals 36, if we write that in slope-intercept form, we would have y equals negative 1/2 x plus 3. This one does have the slope of negative 1/2 that we are looking for. So option D would be the answer. Moving on to question number 7. The graph in the xy plane of a linear function f contains the point 3, 4. For every increase of 5 units in x, f of x increases by 3 units. Which of the following defines the function? So this means there is a linear function, so a line, in a coordinate plane, and it passes through the point 3, 4. For every increase in x, so that means if we kind of draw a graph here, sorry about that, and it passes through the point 3, 4, so 1, 2, 3, 1, 2, 3, 4, we have the point 3, 4 right there. For every increase in 5 units in x, so that means on the x-axis, we increase 5 units. So 1, 2, 3, 4, 5. We'd have to go over 5. F of x, which is the same as y, remember f of x is the same as y, increases by 3. So then we would have to go up 3. 1, 2, 3 to get another point. Notice this line has a slope. Remember, slope is our m, which is always rise over run. And this rises 3, and it runs 5, which means it has a slope of positive 3 over 5. Which of these equations has a positive slope of 3/5? Not A, not B, but answer C. Looking at D, it would not have been D either. So for this problem, you didn't actually have to find the y-intercept. You just needed to understand the rate of change for this linear function. And the last problem for today, question 8. ax plus by equals b. In the equation above, a and b are constants, and 0 is less than a, which is less than b. Which of the following could represent the graph of the equation in the xy plane? Well, first, whenever we're graphing lines, we want them to be in slope-intercept form. So that means getting y by itself. If we were to get this line in slope-intercept form, we would have to subtract ax from both sides. Again, b minus ax, they're not like terms, and we want the term that has x to come first. And then we would divide everything by b. Simplifying, the b's cancel because b divided by b is 1, and 1y is just y. So we would be left with y equals a negative a over b plus, and b over b, again, yes, those b's cancel, but they cancel to the value of 1. That doesn't make a difference for the left side because 1y is just y, but on the right we still need the 1 as a placeholder. So we're going to put a 1 there. Well, looking at this, which graph, and notice I forgot my x, so I'm just going to put that in there. Which graph has a y-intercept of positive 1? Well, the first one does, so that's good. The second one doesn't, right? So it's not option B. The third one does. Ooh, and the fourth one does. Okay, so we're down to a 1 in 3 chance. But we want to get this correct. So now we're going to look at the slope. The slope is a negative a over b, which is negative. So all 3 of those options also have a negative slope. Well, let's look at what else this problem gave us. This problem said that a had to be smaller than b. Well, if a has to be smaller than b, we want the rise to be smaller than the run, because a slope is rise over run. So which graph has a rise that is smaller than the run? Well, in option A, if we find a different point on the line and we count rise over run, our slope would be down 1 over 1. If we think about that, our a and b values, they equal each other. So it can't be option A. Looking at option B, we already crossed that out because that had a y-intercept of negative 1, so it couldn't have been that. So then looking at option C, picking a different point, counting rise over run, our slope would be a down 1 over 2. Comparing that to a over b, we would have negative 1 is less than 2. Ooh, that's a true statement, right? Negative 1 is less than 2, so our a is smaller than b. So it looks like option C is our answer. Let's just check option D because we always like to check our work. If we pick a second point on option D and we count rise over run, we would have to go down 2 over 1. That's our A and our B value. We would have negative 2 is less than 1. That's not true. Well, negative 2 is less than 1. That stumps us a little bit. So what you have to think about for this problem is we only want the A and B values. The negative slope is part of the direction if the graph is increasing or decreasing. So we really only want to compare the values of A and B and not necessarily their sign. So if we go back and we just adjust here to just look at the number in the numerator and the number in the denominator for these two, In option D, the number in the numerator, which is A, is 2. The number in the denominator for D is 1. 2 is not less than 1. And if we go back and check C, the number in the numerator is 1. The number in the denominator is 2. And 1 is less than 2. So again, it was option C. So for this type of question, we're really just checking to see which has the correct y-intercept and which has the correct slope where the rise is smaller than the run. I could have switched this and asked which one is 0 less than b less than a, where we want a smaller run than we have rise. And we would kind of repeat the same process, but just comparing and saying we want to run more than we rise, or we want to rise more than we run. But again, starting with converting the equation they gave us in the top in blue to slope-intercept form kind of helps us see that and helps us narrow down our options. So hopefully after going through these 8 SAT type questions today, you understand linear functions a little bit more and how they can be applied and the different types of questions that may be asked on you on an SAT or even PSAT in the future. Good luck completing today's practice. Make sure you email me if you have any questions or are stuck to schedule a Zoom extra help. Have a great day and good luck.